Hi guys, how are you doing? Today we're going to address today's question. The date is 6th December 2024, and today's question is 2554 on lead code, and it reads maximum number of integers to choose from a range 1. So the instructions: you are given an integer array band and two integers n and maxSum. You're choosing some number of integers following below rules. The chosen integer have to be the range in the range 1 to n. Each integer can be chosen at most once. The chosen integers should not be in the array band. The sum of the chosen integers should not exceed maxSum. Return the maximum number of integers. You can choose the following mentioned rules, and those are the examples. And then we've got those constraints: band length 10 to the power 4, and then band also 10 to the power 4, meaning that they're in the same range, the band length and the numbers that we're going to look at. And then the maxSum can be from 1 to 10 to the power 4, also 10 to the power n, so which is in that part it's different. So we look at the example. So our band, as we can see, we got 165 into the 5. It can be in any order. So usually working with numbers that are not ordered usually makes it difficult in the searching. You could sort it, and then the best sorting algorithm is n log n. Or what could we do? We could sort and then run a binary search, which is log n, which makes sorting quicker. But then we could put these figures in a hash set, and we get all one access to them, making it simpler. And then the maxSum, which is just the range of the addition of the numbers that we're going to do. So how are we going to address this problem? Just from looking at it, at most we can achieve an ON algorithm, with the space complexity of O1, mainly because the size of band is fixed, and then count, which is what we're going to use. We'll see the analysis further. So this is how I'm going to address this particular solution. At first, I'm going to make a hash set, which is going to store integers. Integer. So I'm going to call it band set new hash set. So the reason we're using a hash set is a set because it allows us one access to the data. So we're going to add all the data in band into our hash set. So band set dot add. So as we are adding, we add all the values, right? And then what we do now, we're going to visit all the numbers from 1 to our particular n, and then we check if that number is in the hash set. If it's in the hash set, we don't add it, but we also have a sum. So this sum will keep our current sum. If the number exceeds our current sum, then we remove it. Then we have int our count. This will count the number of numbers we have visited or that are valid to these constraints that we're given. So for int I, which is our numbers, we're going to start from 1, and then a is less than, equal, is less than n plus 1, because it's inclusive of n, as we can see from this part where it says 1 to n. So we say plus 1 because it's inclusive. So 1 I plus plus, so we're going each number one number at a time. So the first condition is we're checking if the sum plus our particular I is less than or equal to our max sum. Then we have an else. In the else, we break. In the else, we break our for loop, meaning we're ending this particular for loop. I usually prefer to put the return statement so that I don't forget about it. So what we're returning is count. So I have my count. So now we have to do a second check. In this check, we're checking if the particular number we are working with is in band set. So this axis is O1, contains the number I. If it contains the number I, so we don't add, so not. So in this case, if it does not contain the number I, what we do is that we say count plus plus, meaning we are adding by 1, and then we say sum equals to plus or equal to I. Then we've added our values. So that's our solution. So this particular hash set is a lot of people might confuse this part of the hash set and think that the space complexity. As we said, our solution is time complexity is O(n), and our space complexity is O(1). A lot of people might confuse this part and think that it's O(n) because we're copying the number of band. But if you remember, the number of the length of band is fixed, so it's a fixed number. So at a particular point, that particular size remains constant. In this part, we would have used an array with the size that's 10 to the power 4, and actually use maybe true or false values. But this particular part makes it O(1), and then our time complexity is O(n), because we are looping through n numbers, though sometimes we might not reach that part. So it's O(n), and then this particular instruction is a O(1) instruction, because we're just getting data from a set. And then this is O(n), of which the n is size length of band. It's actually it's the same size as n, as we can see in our constraint. So that's our solution. I'll just run it just for confirmation. Maybe we do have errors. Or I just have to remove this particular part where I was talking about, and then rerun it. Let's see where our error is. C contains I plus plus count to maxSum plus less than A plus sum. Alright, let's see where we got our logic wrong. See where band set dot contain. an alcohol L spray. Logic looks a bit correct. Oh, started our count from 1 instead of 0. Okay, that was my bad. So this count was supposed to start from 1, from 0. That's our solution, guys. Sorry about the mistake in the end. It happens when you're coding. Those slight mistakes are the difficult ones to fix. But yeah, see you tomorrow. Hoping to do these daily challenges every day. Let's see how it goes.